just want to say I'm Ed Keebler, this is Jaden. We're going to talk a little bit about seat and guide machining, but first of all I want to say what a great program we've had up to now. My gosh, you've had Warren Johnson, the professor, and we just got to hear from Ed Pink. Two amazing gentlemen that have been absolutely, just historic in this business, and great people and great engine builders. So what we're going to do here is we're just going to talk a little bit about seat and guide machining, and Jaden's going to, I'm going to kind of turn it over to Jaden and let him talk a little bit about what we try to do here and what they're looking for here at Straub Performance out of their seat and guide machine. So Jaden, I'll kind of give you the reins here, and just what are you really looking for when you're cutting seats or trying to cut seats on these seat and guide machines?
The biggest thing that we like to look for here is concentricity, and that's something that this machine has been able to give us. And it took a little bit of getting used to going to this machine from an old foot pedal style, I guess, like Sunin, and I think Tobin Arp was the old one that we had. But this machine allows you to cut seats that's actually really pretty concentric. We've got Rottler's concentricity gauge up on this exhaust seat that we kind of just roughed in. You might not be able to see it, but Ed can probably see it. Just spinning it around on this 45-degree angle, I mean, it's about 6/10 probably of run out. Yep. On a 1/600 valve, and for what this is going to be using, that is good enough for us.
And what features on the machine, Jaden, do you think allow you to get to that point, that type of accuracy?
One thing that helps is the pilot system that this machine uses. It is like it's like a fixed pilot. It actually goes into the guide, and I'm not going to say it locks into place, but it sits still. It doesn't spin inside of the guide, so the actual tool body rotates around the top of the pilot. So in our opinion, that's what helps get us the concentricity that we get out of this thing. And it also allows, because the pilot locks into this head, you can move from hole to hole to hole, and you're never pulling a pilot out and sticking it in the next guide. Once you lock it into place, you don't have to touch it until you're ready to move the head out of your way and check things.
So the ability of the pilot to lock into the guide gives you, what it does is now we can control the clearance, so to speak, from the pilot to the body itself.
Correct. We
control that, unlike a pilot that might spin in the guide. Unless you can control the pilot's eyes very precisely, you end up with some varying seat concentricity issues.
Right.
With what we would term a live pilot.
And with these pilots, for something like this being a GM 243 cathedral port head, this takes an 8mm valve. We have, I think, 3 8mm pilots, and 99.9% of the time we may just use 2 pilots, so we don't have a big case full of different size pilots to get through each application. We have 1 or 2 that works for most of the things that we do.
And what about the seat profiles and all? Jaden, do you have specific seat profiles that you all, not to give away your secrets, but you have specific seat profiles that you guys like to use on exhaust and intake seats and maybe different applications?
Yeah, we have a basic intake cutter that we like to use on most general applications, and having the little bodies that just slide in and out of the main holder. It's really quick to set up, so you can go through, cut all your intakes, check your depths. Same thing with an exhaust. We use more of a radius style cutter on it, and with the shelf that this thing comes through, you can keep all your bodies set up as long as you don't mess with your set screws. I could go from something like this to like a big block Chevrolet head, have it set up and cutting something in 5 minutes, as long as I haven't messed with, I guess, the cutter that's sitting there, or have to go to some arbitrary valve size that I've not done before.
Okay. I noticed you said something about on the older style machines and a foot pedal. Explain a little bit about what you're talking about there. This machine doesn't have a foot pedal on it, so how do you control the operation of the machine without a foot pedal to allow it to float?
So with something like this on this screen, you have what's called a float height, and then you have a vertical position. Your vertical position is like what you would set your 0 at, touching the seat. Your float height is actually when it unlocks the clamps So just by moving this wheel and getting it to go down, moving this down will allow that to go hole from hole. So whenever you've got your pilot in, you can pick the head up, you go so far and it'll lock it. You go down, move from hole to hole, you can bring it in, center it into your valve guide, bring it down. It'll get to whatever location you put on here. So I've got 200 thousandths above the seat. We'll just change that to right there. Whatever number that you decide to set it to, it will actually go. It should center itself, which it's being a little finicky right now. But it will center itself. You let go of the wheel, it'll lock itself back into place. The light will flash. The spindle will actually turn itself on. Then you can start cutting. You can set your other depths in here so another light will flash, so you can have a different roughing RPM and a different finishing RPM. So you can take your last two cuts or whatnot at a slower RPM to get a better finish, or faster, or whatever you prefer. So there is no foot pedal to sit here and shuffle with trying to go from hole to hole. All you got to do is grab onto this right here and you can go with it.
So the linear encoder in this machine gives you that opportunity to where no longer, from an ergonomic standpoint, if you were to have to stand here all day long and operate this machine, not having to step on that foot pedal and kind of hunch over a little bit, especially for a taller fellow like you, makes a big difference.
Yeah, it's really nice. Like you said, you're not hunched over. Everything is right here in the control of your hands. Once you set it how you want, you can really fly through these things.
Can you tell us a little bit also about, I notice on the screen there's some different buttons up here, and one of them I believe says for reaming, and one of them says for tapping, can you explain a little bit about that, how the machine will actually, I don't want to say automatically tap for you, but has the ability to reverse it?
Yeah, so at the tapping page you can go over here and it'll change everything that's on the screen. So each of it's kind of personalized to whatever tab that you're on. You've got your intake and your exhaust. Those profiles you can save. You've got tapping, reaming, and drilling. So with tapping, again, you can set your start height, you can set a finish depth as far as where you're going to go with the tap, and you've got your vertical position and your spindle RPM. You can feed it down, and as you're tapping, once you hit your finish depth, it'll actually reverse the spindle, and you can feed the tap back up into it instead of having to, turn it out by hand every single time. So again, something like that really allows your speed in the process to go up very, very quickly. So
the machine will actually reverse for you and pull the tap back out of the hole that you're trying to tap. Correct. Without you having to shut the machine off or to reach up and reverse the spindle.
Exactly. So it takes pretty much any of your time-consuming issues right out of it.
Okay. And can you give any recommendations for people? I know we get a lot of calls about how fast, seat cutting. What kind of RPM should I use while I'm cutting seats? Do you have a preference there?
I have a preference, but with each head, it's all different because every cylinder head company is going to use a different valve seat material. So they're all going to cut different. Valve diameter changes, and that can all affect if you're using a fixed cutter, if you're using a cutter with just a single angle. They all change the same. Generally, I don't have it sitting out here, but the manual for this machine gives you a list of valve diameters, gives you about a rough RPM you can use.
Okay. And
that'll get you actually really close to what you need. You can vary 10 or 15 RPMs from there.
So do you have just a kind of a ballpark figure to maybe give the audience, depending on if it's a compacted graphite or something like that? So actually we'll follow that up a little bit later. What we're going to do now is we're going to go ahead and go to some video of people operating the machine. So we want to thank you again. We want to thank Ed Pink and Warren Johnson for their contributions, and we'll go to the videos now.
Hi, I'm Anthony Franco here at Larry's Auto Machine. Machinist here for about 16 years now. Want to talk about this new machine we have here. We purchased it about a year ago, and why we purchased it and what it's all about. One of the things we struggle with day to day is making sure we have a product that will produce an end result within fractions of a thousandths so we can be assured that we give a customer exactly what we say we're giving them. We had looked at a lot of different stuff, but we came across the Rottler booth and saw this SG9 there and thought that maybe that was something we needed to have. Upon the research we had done, we found out that it would be a good fit for our shop. One of the things we had struggled with in the past is finding a machine that could cut valve seats of different materials and produce high quality of accuracy. So some of the key features on this machine is how it sets up and how quick it is. And you'll actually take and move the valve, move the pilot into the valve guide. And it has a feature, it'll actually center itself. And once that's centered, and your parameters are set as far as your depth of your cut and your speed of your cut, it'll self-start. And as you can hear the pulsing starting, that I have the high performance on, because this is one of those jobs at the size of the valve seat and how hard it is. We don't want all that compound cutting. Rottler has developed a screen here that allows you to set your final cut, your speeds and your feeds, whether you want to run the high performance, which would be the pulsing or the changing of speed as it cuts to keep from that heavy cut and chatter. It has your final depths on it, and it's as easy as just, once it's set, moving into your automatic mode, centering it in the guide, letting it self-center, starting it up, cutting it. Yeah, we were looking for a machine that could change speeds, and due to the load on the cutter, the diameter of the material in this machine, they designed that would be able to change speeds during the cut to reduce the load on the cutter, giving you a better, more concentric valve seat. We really like the machine, and we know that at the end of the day, when we do a valve job with this machine, that we're giving the customer a really accurate, good product. And that's what we want to do here. We want to provide a service that we feel really good about at the end of the day, that the customer's getting what they paid for. So one of the things we do here, we do everything from your foreign car, your RB26, to your big block Chevrolet, aftermarket heads, stock heads. One of the things that we've done with this machine is it has a high performance fixture on it that allows us to change on the fly. You can actually see the difference between this design cylinder head and this design cylinder head as far as setup, that it has this fixture. We're able to change it up real quick and still produce a number.
We started out with actually a sturdy 100 seat guide machine, which is a good old machine, but it's not near rigid enough to do large valve seats, bronze alloy seats that cut so much harder. That just, the machine's a great machine, but it's just not near sturdy enough to do them. So we upgraded to the SG9 Rottler seat and guide machine, probably in about probably 2010, 2008, something like that. And that really helped us put them much harder seats in, get our valve jobs concentric, with close to thousandths and stuff like that. That really helped us out in that. We still had some chatter issues, because you get 2.5-inch valve or bigger. We do valves, 2 800, some engines these days. And it was too hard to get the chatter out of some of these, so we upgraded the SG9 HP machine, which has a variable spindle speed. In some applications, that really helps control the chatter and get a really concentric valve seat.
My name is John O'Neill. I'm a cylinder head tech here at BES Racing Engines. Been here about 4 years. Come from Wichita, Kansas. Growing up, I raced karts. My dad and I raced karts, and got bit by the bug, and decided to make it a career. So I've been here about 4 years. I worked for Roush Competition Engines for about a year before this. I went to school at Samtech. Today we're working on a set of headhunter heads, big block Chevy heads. This is going to be set up for a nitrous combination. So we've got the head shifted around. We did a soft chamber on it, and we've got a valve job on the Rottler machine. The seat material, this seat material is called Ampco 45.
Okay.
This doesn't have beryllium in it.
Okay.
It's I believe it's an aluminum tin alloy. So there's no beryllium in this one. This isn't typically what we would run. These heads came to us from Brodix with these seats in them. Okay, we're going to do a 55-degree valve job on them. That's our competition valve job. This is going to be a pretty high effort deal. We have a 5-angle form cutter that we cut our valve jobs with, and then usually there's some hand blending involved. So, you know, depending on the intake or exhaust, it might not end up with all 5 angles in there. So the SG9 HP, this machine is great. They've got some digital controls in here for speeding up, roughing in square seats, which square seat is a seat that gets driven into a head. There's no angles cut on it. So we're starting from scratch. We've got some high performance modes that it's kind of like a rapid feed. In the past, I had used some SERDI machines, and you did that manually by moving the knob around. So this machine does it for you. Depending on where your depth is that you want it to stop at, it stops automatically. It just takes some effort off of your hands to get the job done.
Hi, I'm Tyler Eicchorn. We're back here at NPR Racing Engines. We're here to talk about our SG9 Rottler machine. We've had this machine for about 6 years. The start of it, when we were first looking at it, we were at the PRI show. We were talking with multiple companies, trying to get some more information out of each machine that we can see. We had our eye on 2 of them, but it ended up being we chose the Rottler machine. Their personality is amazing. This machine actually has a lot of crazy things that we're about to show you right now. So the first thing that we know when we bought the machine that we were really excited about was a centering pilot. Not a lot of companies out there offered that, and we wanted to be the first ones to try it out, especially because we were working on a smaller valve engine. So we wanted to really incorporate that technology into the smaller engines, and it actually paid out great for us. So usually on the intake, this is our stage 1 Coyote head that we have right now. It's not ported. We do replace the steel guides that are powdered metal and tend to either break or they just wear out over time. We replace them with a bronze guide. And what we usually do on the intake, we offer a 4 or 5 angle depending on the competition that he's going to run. Usually street cars, we like to keep a 4 angle. You don't need as aggressively as a race car engine. And then we move to the exhaust. Over time, we had a test now running more power outers than anything, making a lot of horsepower and a lot of heat. We had to go with a radius exhaust valve. That really helped the air flow out of the exhaust and just get all that hot air out of the engine so it can continue to make more power through the intake valve. So when we were developing a cutter that we had to use for the exhaust, we're running into the issue of what angles we can run to get the heat out as fast as we can. We found out that the radius, and it took a little bit of tries on what radius cutter actually worked the best, but we found one and it exceeded our expectations. So one of the big reasons why we chose Rottler was the tooling aspect. The biggest thing that we have with small engines like this is it's either a long time to get the tooling for it or it's impossible for them to make it. And Rottler they never backed down on whatever we wanted to run. We came with them with an idea of what we were trying to do, and they were like, let's do it. Let's make it happen. They really advanced our design of this cylinder head because of the tooling that they provide. They always have it on the parts. I break some pilots all the time. They're next day air, I'm getting them. They always have them on the shelf. I really don't have to wait for anything. It's really second to none. So after we have the cylinder head clamped down, it's basically time to do the valve job. And what we do, we level it all up. We get it centered with this tool. This basically points where I want my 45 or whatever angle I want to be at. I set that, and then I grab this tool holder here. It's set up for the intake now. I set my cutter, and then I basically, after that, I set it and I don't forget it. I don't have to worry about multiple cutters that I have to use. A really nice 5-angle cutter like this works perfectly fine. And then I also have one for the exhaust, so I'm not bouncing around on tooling. I'm not fumbling. Because I have to do 2 heads, so it's not I do one, break it all apart, and then I'm wasting a lot of time. So the Rottler really helps us perform and perfect a lot of production work that we have, but it also allows us to do more development work and finding exactly what these things love and need.
Hi, I'm Chris Straub with Straub Technologies, and I'm here to show the Engine Pro Black Nitro Valve train that's available for the LS through any Engine Pro dealer across North America. The Engine Pro Black Nitro Valve is a premium valve designed for power adder applications and naturally aspirated. It's available in the LS, small block Chevrolet, small block Ford, big block Chevrolet, and big block Ford. This is also available with a complete line of valve train products from the Engine Pro brand, which includes retainers, valve springs, and seat locators. This all comes packaged in Engine Pro brand, which is easily recognizable. Today we're going to look at this product being used on a Rottler SG9 and an LS casting. Let's see what we can do.
I'm Jaden McCurry here at Straub Technologies. I've been here for almost 3 years, mainly running the CNC machine, but I have run the seat and guide machines, valve grinders, and pretty much done all the processes with the cylinder head building here. One feature that I really like about this machine is the pilot system that it has. It's not so much a dead pilot that you have to move in by hand. It actually locks into the head so you can go hole to hole, and the pilot still functions as a dead pilot, so you still keep all your accuracy and you gain your speed without having to touch the pilot every time you go from hole to hole. Yeah, so we're going to go ahead and start cutting these valve seats. You've got different features in with this software. You can go to a manual setting, so you can do like a one-off if you're doing port development or something like that. And you can go to a production cycle on the other side of the software, and you can actually put in your settings and the depths that you like and go hole to hole. And as you put in the height that you want it to start, you can actually let go of the hand wheel and it will center itself, lock itself into place, and the spindle will actually start turning. You can feed down, cut to whatever depth you like. It'll flash and let you know you can pick up and go to the next hole. Generally what we see here with the Rottler, after you get the feel for the machine, I mean, it's nothing for us to keep a valve job within, 5/10 easy or better. And the valve side doesn't really affect that. It's pretty accurate.
Rottler valve refacing machines works really great. It's a centerless valve refacer as opposed to a colleted style, which would, you know, you're centered on a collet. Well, if the collet's in concentric, your valve face is going to be in concentric. With this machine, we surface, you know, a lot of big block, small block Chevy valves, big block, small block period valves. We also do a lot of our mod motor refacing here, so it works for anything from, you know, we do a lot of 3/8 stem stuff down to 5.5 stem stuff. We have ground Honda valves on this grinder before, so it's super versatile machine. The smaller the valve gets, the more concentricity is a big deal. A thou on a 2/400 valve is a smaller percentage than a thou on a 1/200 valve. So this machine does a great job of keeping everything in line. It's all based off of your stem. So if your stem's straight and not worn, your valve face is going to be straight. So I'm going to start here with grinding this tip of this valve. The tip of this valve right here is in pretty good shape. This is a hardened tip pressed into a titanium valve. And it looks pretty good, but we're going to surface it, make sure it's flat, just in case. Because if that's worn, then everything downstream is going to be wrong. So we need to make sure that that's flat, and then we'll go from there. So this is just another stone rotating in here, and I've got a guide in here that I just stick the valve into and spin the valve as it's facing. And you can kind of see the crosshatch on there looks different than when we started, and it's cleaned up all the way around the tip. So that's a good valve. We can proceed to facing it. This engine in particular had a 55-degree valve job. That's what the face itself looks like. You can see some cupping in there. I don't know if you can see that light moving around on the face of that valve. But that needs to be ground. If we're going to do a valve job on that and we stuck that valve back in the head, that would not seal. So we need to set up our machine to grind at 55 degrees. There's a little vernier scale down there. It tells me what degree the machine's set at. When I'm grinding this, I need to keep the valve moving back and forth so that my stone wears evenly, so that my angle stays consistent throughout my entire setup and process here.
Yeah, that VR12 machine, especially when you grind a lot of titanium valves, and it's a centerless grinder, which makes the seats perfect as far as being concentric, and it's so smooth that it grinds that titanium, so you can get a really nice finish on that valve. So that helped us a lot.
So that's how it looks when it comes out. Nice flat 55-degree cut on my valve.
I'm Chris Straub, and we want to welcome you back to the Engine Performance Expo. And we've got a bit of a treat today because of some technical difficulties with going across the pond to Nathan Higgins of Higgins Raceheads over in Australia. We've also got John Callies batting cleanup if we need to. So you're going to get a double shot of cylinder head technology. We could talk about some Cleveland stuff. We could talk about some SB2 stuff. We can talk about some 18-degree stuff with John Callies. And we can talk about some Pro Stock stuff with Mr. Callies, two heads that he developed. So let's see if we got Mr. Higgins live over in Australia. Looks like we've got a little mic deal, so while we're waiting for Nathan to come up and on.
Is that it?
Yeah. We got you, Nathan. Glad to have you. We can see you and we can hear you, bud.
Well, it's just cut out a couple of times, but we're here now, so let's go for it.
All right. Let's start out with a little history on Higgins and a little background on you, sir. There goes that technical difficulty. So we're going to try and get Nathan back in here. You know, we're trying to do this over the ocean. So, John, let's come back to your cylinder head development days at Pontiac, and if you want to start with the 18 degrees 867, or if you want to start with the Pro Stock stuff.
No, the first head that we did was the 867 head. This was back in the 80s, and what was happening in NASCAR was the Chevrolet head that was using was like a big sprinkler. At the end of 500 miles, it had more leaks than when it started. So we did a new cylinder head and got it approved, and it had a run of about, I guess, 6-7 years, and everybody who was running, including the Chevrolet guys, ran the Pontiac head. So, you know, it was a little, but we probably had more competition between Pontiac and Chevrolet than we did Pontiac and Ford or Chrysler. So it was a wild deal. But that was a very good, the head turned out, the fellow that actually developed the port work was Mike Kennedy down in North Carolina. And actually Mike, we set up, he was one of the people that worked for me in the race program.
Okay.
And Mike did a terrific job on it and developed the head. Then we cast it, made it, drew it up so it would work. So
okay.
It was success. You know, it was a successful piece.
Now, you've told me a couple stories about an announcement over the intercom at one of the races by NASCAR. Could you share that little story with us, Mr. Callies?
This was back in the 80s. We were racing at Charlotte. And, of course, I had to give NASCAR the original cylinder head, and they carried it on the truck. So if somebody had it pulled off the engine, they could, excuse me, they could look at it. And so I was called to the NASCAR trailer, and all the tech guys are standing around, and they had pulled a head off Junior Johnson's car, which happened to have our head on it. And they're pointing to the floor of the port and saying, look at the difference between the first. And I go, what are you looking at? And they said, right there, don't you see that it's raised there? And I go, boy, you don't know anything about castings. That's just core shift. I can't help it. And I walked out the door, and they bought it. So it was an example of lucking out on, you know, saying it was okay.
Now, the 867, so that was an 18-degree head. So, and I know that head started to get modified, and they would roll it to a 15, any a 13. So, can you talk on that head kind of being the building block of modern-day cylinder head valve angles and stuff?
What was interesting is when we did the four-cylinder program, we found that the valve being 90 degrees to the piston top, that you had way more flow area and flame propagation. And so on a V8, trying to make a 90-degree valve angle, trying to get a push rod in became a chore.
Okay.
And even now, today, they'll build some 11-degree heads, but then the guys have no way of running the push rod. So I found that out, and I had John Lingenfelder. I took two four-cylinder heads and made a V8, and he run it, and it proved that the power gain was there from standing the valve up.
Okay.
And so that's what led to going from a 23, 18, 15 on down.
So So really, the industry has you to thank and Pontiac for the start of the rolled valve angle and where we are today.
Yeah, I mean, it really was. And it really came from the four-cylinder program.
Okay.
Yeah.
All right. Yeah. What can you tell us about NHRA Pro Stock and Pontiac?
Well, again, the only head that was used was the Chevrolet Big Block, and you'd weld on it for 2 weeks and then roll it over and change the ports. But it was so modified that it wouldn't last for any duration. Plus, it limited you had Eicchorn, you had Rear and Morrison, and a few others that were doing that to the heads. So our factory team was Butch Leo, the rod shop, and we said, why don't we just make a new head and roll it from the beginning and put the big ports in it. And so actually that's what was the start of the big block cylinder head. And you know, Butch was our driver. He won a lot of races, was a great guy. And so that became a success. And of course, every cylinder head after that is kind of copied off that program.
And today, your head, the basis of that head is still used by
Right.
in pro stock racing and the large cubic inch stuff and everything about that.
Right.
So
right.
now you had some involvement. I say it's a little bit of involvement, a lot of involvement in the Fiero program and that car. Can you tell us a little about the cylinder head and the engine development just in the Fiero?
Yeah, and we're going to talk tomorrow about the Fiero pace car, but we started out with because we were going to be a pace car at the Indy 500, and they had certain requirements. I had to develop a new block and cylinder head in a short period of time, and we started with doing a new port design, and a fellow by the name of Paul Vanderlee of Vanderlee Engines worked, and he developed the port and the dyno work. And anyway, we cast that head, and then as the race program progressed, we made an aluminum head, and of course all our aluminum heads we went through Brodex.
Okay.
So the Pontiac program was really all developed based on the aftermarket. And
Okay.
it was making relationships with people so we could get parts built fast.
Now, like in NASCAR, did NHRA or IHRA call you to the trailer about any cylinder heads and in that, or you know, I know with Oldsmobile and yep.
Yep. I mean, the thing was Olds and Warren, they did the first big block head, and we had I did the new Pontiac head, and what was wild is we had the cars built going to Pomona, and a farmer called up and said, well, we can't approve your head. And I said, what? He said, you never build a Pontiac with a big block in it. Well, then we produced 290 numbers of Canadian Pontiacs with big blocks in it and got approved. So, you know, another panic and then a solution, you know, and that was pretty cool.
Now, your experience with the 867 Pontiac small block, did you take some of those valve angles and what you learned with that head and incorporate that in the design in the big block head as far as the Pontiac head?
Well, the big block head was so different in those days. You know, like Warren was saying, the flow bench isn't, you know, it isn't right the way it's done, but that's all we had to work with. And Dale Eicchorn was the head porter at the rod shop.
Okay.
And so Dale developed the port, and then we shrunk it down so anybody could do what they wanted to do the port, but we didn't give the exact design away. And what was interesting is we went out to Pomona with the new heads, and Butch won Pro Stock that year.
Okay.
Yeah, Pomona.
Okay.
So, cool deal.
And then with an OEM working with the aftermarket and stuff, so did you actually at Pontiac design the rocker arm system, or did you rely on outside sources, say like Jessel, to do the rocker arm?
On the when we did the big block head, of course we had drawings of all the ports. You know, we'd saw the head up and all that, and we sent drawings down to JV, who is the owner of Brodex, and it's probably the first head print they had ever seen. So back in the day, we had a lot of fun back and forth of, you know, what the head ought to be and how do you build it. And the valve angles are just they're doing great, you know. I mean, and so the Pro Stock thing in the day, when you do a dyno pull, you would have 5 guys in the room, and each guy was responsible looking at one gauge. And so when you pulled it and you'd come up to 8,500, you'd shut it off right away. You'd run it for about 2 seconds, and then everybody tried to say what they saw. I mean, it was pretty crude, you know, compared to where we are technology today.
budget-wise, as far as the OEMs with that, I mean, did you have a budget, or was it just whatever you needed Pontiac supplied?
No, the money was very limited. So we were on a small scale. I had 3 people in my group doing the race parts and working with the aftermarket. And the aftermarket was a big support for having a race program at Pontiac. And, you know, we did it on a shoestring budget. Example, let's say my budget was $5 million for all types of racing. Chevrolet's was $25 million. So,
Big difference.
So, you know, we were the small guys trying to compete with the guys with a lot of money. So, fun time. It was you know, you worked your head off. So it was good.
Well, we do appreciate you being here with us during this whole deal. And John, we can't thank you enough. You know, your contributions to the industry and what you've given us and a future. And with that, we're going to take it to Lake Speed Jr., and we're going to talk about some sponsors. Take it away, Lake.
Thank you, Chris. Appreciate it. So far, what a fantastic day. A couple of technical glitches along the way, but hey, that's expected when we're doing a live internet-based show, and we've got people Skyping in from all around the world, but things are going really great, and we want to thank everybody that's made this possible. One of the guys you were just listening to, John Callies, not only is he synonymous with Pontiac and crankshafts, also Morel Lifters. We want to thank John and Morel Lifters for sponsoring the Engine Performance Expo. Of course, we couldn't do this without Rottler, Total Seal, Piston Rings, another big sponsor of this event, making this all possible. Then Randy, CWT, we saw those guys yesterday, big backer of the show. Higgins Performance, you know, he was trying to get Skyped in from Australia, a couple technical glitches, but we thank them for sponsoring us and being part of this anyway. Samtech, we know that, you know, some of the guys who are watching are at vocational schools. And if you're at a voc tech school and say high school and you're looking at this as a career field, you need to consider Samtech as one of the choices and can continue your career in the motorsports industry. Because the next generation is you, and we want you to be here and be part of it. And Samtech is a great place to start that. Qualcast, Edelbrock, Comp Cams, these are the guys that are making the valve train section possible. We appreciate that so much, and that's what's going to come up here in a little while. Chuck Lynch is going to be up next with Joe to talk about some other things, but later in the day, we're going to have Billy Godbold, Ben Strader from EFI University talking about valve trains, so we want to thank those who are sponsoring, making that all possible. Couldn't do it again without Holly, Melling, Elgin, Driven Racing Oil, Promax, and the Turn 2 Vice. And with that, we'll throw it back to Joe to hear from Chuck.
What a day, what a day, what a day. My brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.